Welcome to this episode. It's about a number of things that are more social and legal than they are technical and data-driven, but they're all important. So we're going to start off talking about Factfullness. You'll know the single compulsory set book was Factfullness, and I think it's important that you read it at some point during this year because it sets a context for how data is reported. And even if you don't agree with the way it's written, you should certainly think about these issues carefully. And one of the things that's said about data science and statistics is that the goal here should be for us to inform people but not try and persuade them. So we're trying to get anyone interested in data informed about the data, about what its meaning is or what the signal in the data is, or what its certainty is or what its uncertainty is, but we're not trying to persuade them to take a particular course of action. An active concern, and certainly in society, is bias in data and products of data science. It's an issue that's widespread and in discussion. It's not one that I'm going to spend too long on here because of its complexity, but we'll say a few things about it here and on the way. So first of all, bias technically is not uncommon, and systems that show bias in that sense deviate from a set design requirement. And they might deviate in good ways or bad ways, but they're not fulfilling the requirements that were set out at the beginning of a project. A way to ensure that technically things do what you specify them to do is to do robust technical testing, and software engineering has a whole host of testing processes and approaches, black box testing, white box testing, all of those things, tool sets that are available for testing the system performance itself. And then another area of concern for bias is the human aspect of bias. Systems not deviating from technical requirements, but deviating from people's expectations, everyday common sense for people, everyday understanding for people. And there are not many ways to fix this one. Extensive social testing can help, but extensive social testing is often a very difficult thing to do fairly and reasonably. And you'll come across later in the course more statistical approaches to doing some of these things. You can think of a couple of good examples in the press at the time I'm talking. One of them is in the UK, the 2020 A-level result estimation algorithm. It may possibly be the case that that algorithm met its targets, that it did what it said it was going to do technically. There's an investigation to find out going on right now, but it certainly didn't meet its targets humanely. It was not predicting the correct grades for the right people. And I guess statistically, maybe across the board it was working fine, but for individuals it wasn't working fine, and that's a really challenging problem. Another area I've worked in is face detection and tracking algorithms, and this has caused some concern in a number of ways. One of which is misidentification of people, and one is biases of data sets and or algorithms towards people of different skin colors. And I can tell you, having done this, that getting a face detection system to work for people who have different skin colors can be very hard. Cameras don't detect darker skin colors as well as they do lighter skin colors normally. And in most situations, fewer features are extracted from darker skin tones than they are from lighter skin tones. But we did solve this in the systems that we built by using hue. And the hue is just, you'll remember from the color episode, the basic skin color, independent of brightness level. And if you process all your images into a hue space, then you can see that there's almost a unique hue for all skin tones. Even so, it's not straightforward, and there are lots of challenges doing detection and tracking algorithms. And certainly in facial recognition and identification systems, the challenges are even harder because you're trying to pin down a specific person rather than just detect a face in a scene, which was the thing that we were doing. There's a great challenge in face detection and tracking. It's an incredibly easy thing for people to do. Your brain and your visual system has evolved to detect and see faces. And if you remember back to the Charlie Chaplin example, it won't even let you see an inside-out face. It will flip it and show you it the right way around. So to people, finding a face in a scene is really easy. For computers, it's much, much harder. And finding one, recognizing it from the background, and then identifying it as a particular person is a technically extremely hard problem. So it's not surprising that it doesn't always work. Coming back to bias, most systems are designed to be biased. Most systems make choices, and that choice is a bias one way or another, or multiple ways. They sort things, they produce choices about things. And the question we have to answer is, are those choices the ones we want always? And how many of those choices have to be correct for a system to be useful? And then a philosophical question that comes in here is, underpinning this, what's the unbiased position, and who's deciding what is the point at which a choice is made? It's very often the person paying your salary if you're a data scientist, but that doesn't mean that systems are being designed in some global God's eye view of the world where there's an unbiased position on everything. Most systems will make biased choices, and it is a question there of what utility those have. Well, you've probably got many of your own thoughts on that, so I'm not going to dwell on it. Someone who's been very influential in parts of data science is Hans Rossling. He was actually a health scientist working on, among other things, the Ebola outbreaks. And he asked a question, what should we do in data science to be more ethical? What things can we do to improve the way we present data to people? And some of his concerns were the press very often isn't asking this question, it's asking some quite different questions. And some of his concerns are that, for example, the press isn't trying to ask questions about what level of factfulness should we have. They're asking questions about how many newspapers can we sell. For example, how impressive or eye-catching or sensational a headline can we put on a screen or on a newspaper to attract people's attention to buy our news products. And coming back to this unbiased question, what is it that you need to do to present data to people that informs them in an unbiased way? I'm not going to go through all 10 of his recommendations, but we'll just drop in and see one or two of them in more detail. A very big thing he had was about gaps between rich and poor, gaps between all sorts of groups of people, haves and have-nots across the world, and the way in which it's very often presented as a binary thing. There's a group of people at the very bottom and a group of people at the very top, and look how different it is. And then you miss out in the middle the distribution, the spread of things like wealth across the world. Negativity is another one that he was very concerned about, and he's been criticised for being overly positive, just to set a contrast here, but he was very worried that negative news is what sells, and more bad news isn't always bad news. It may just be that on the day we get very bad news, and the next day the trend continues to move upwards. But the thing that will sell the papers is if it's all going badly wrong, and that's the headline that will work to grab your attention. One of the things, and we saw this in the Department for Transport data, is don't assume trends will keep being the same trends. Don't assume straight lines will keep going. Things might change. And in the transport data, you saw the government policies on loans changed and the car sales started going up instead of trending downwards. Managing fears is a very timely one, and the description of this is that you should look at risk rather than at danger. And you should look at how dangerous something is times the chance of exposure. So how likely is it you will be exposed to a dangerous thing? And that's a really difficult question to answer. You can think at the moment about the COVID pandemic. It's quite dangerous. We know it's about 10 times more dangerous than flu. But what is the risk of exposure? If you're exposed at a certain age for a certain length of time in a certain place, are you likely to get it? And if you are likely to get it, is it even likely to be in any way health or life-threatening? Size, look out for impressive numbers. If people have impressive numbers, there was one only yesterday, the day I'm recording this, that was a very impressive number. But if you dig into the details, it turns out that actually it's a not so impressive, but it's worrying, but not so impressive number over the time it really reflects. Generalization, categorizing things. Now, this is something humans like to do a lot. I mean, you can imagine left versus right in politics. Two categories, are you for us or are you against us? It makes decisions nice and easy to do that. But while they can be very useful for summarizing groups, and you will do that kind of thing in k-means type analysis and statistics all the time, you'll try and extract groups, different groups of people for different reasons, different groups of products for different reasons. But question those categories relentlessly. So are there better categories? Are there different categories? Do we need categories at all? You can look for differences and similarities in and across groups, and always check how big the majority is. If someone says that there is a majority of people in favour of something, Like the Brexit vote in the UK, it might just be 51%, and that is not a big majority by any means. Destiny is an interesting question. Just because change is slow doesn't mean it's not happening. And this is kind of like compound interest. If you have a lot of small changes, they work towards something that's a big change that in the end makes a big difference. So make sure you track gradual improvements, not just the big steps up. Update your knowledge continually, because the world around you will change through your lifetime. Take multiple perspectives. I think that's kind of straightforward. Blame's a great one. People like to blame single people, but look for causes. Look about why things happened rather than blame, because it's usually there is an underlying cause, which was time, pressure, or lack of data. There's usually a reason why something isn't working. Finally, resist sturgeoncy when you can. There's usually someone somewhere needing data to make a decision today, right now. If you can't do it, just say you can't do it. We've seen before predictions. Beware predictions, and beware predictions which don't have uncertainty attached to them. If someone's being certain about the future, you can be fairly sure it will not be the way they think it will be. So finally, I'm going to show a video alongside this. I just wanted to say a little bit about trust and trustworthiness. And this is Baroness Honora O'Neill from Cambridge University. She's a professor of philosophy. And she's thought a lot about trust and what it means to be trustworthy. And this was presented in the context of data when people were trying to be more transparent, so publishing more and more and more data. And her observations, which were put into a Royal Society report on open science, are that 3 properties can help generate trust. It's not just having a pile of data, because that might not be useful in it at all. Is the data accessible? Can you access it? Do you have to buy a very expensive software tool to get the format of data that the data has been published at? Usability, can you get even relatively cheap tools to access data that is in a form that's been published? And finally, accessibility. Can you test data? Can you compare it? Can you reanalyze it? Can you assess its quality and compare it to other people's versions of the same data? So these 3 properties: is data accessible, is it usable, and is it accessible, are very important in data science and open data. And even within a closed company, you still need data to be all these things to the people who need to use it.